Okay, so now we're on to part 3 of looking at what AI, artificial intelligence, says about Einstein's special relativity is wrong because it moves goalposts. So, general note, when people talk about light speed, it often just means light speed in vacuum and in context of inertial frame without influence on it by such fields as gravity. In other contexts, it means something else. So this is the paper that starts all the problems, Einstein's 1905 special relativity paper. So there are numerous problems with it, but can't go through all of them, just can pick up a few of them. So in part 2 I ended with a ChatGPT. It gives a different conclusions based on different criteria. In the case under analysis, ChatGPT was prepared to go by my criterion and conclude Einstein's relativity is wrong. But ChatGPT is prepared to go by mainstream criteria and reach their conclusions. So from different points of view, you reach different conclusions based on different criteria. So hence why, as pointed out in part 1, can have different philosophical viewpoints for physics. Next I get diverted to the Lorentz theory and wonder if the same thing of moving goalposts applies to that theory, and I ask ChatGPT straight AI about that in the context of Lorentz theory versus special relativity. So is Lorentz theory like special relativity moves goalposts a lot? AI, artificial intelligence, ChatGPT starts Lorentz ether theory versus Einstein's relativity or special relativity. And the ontology, a basic framework is the Lorentz theory has absolute space and time exist. Light speed is constant only relative to the ether. While Einstein has, in special relativity, abolishes absolute time and ether. Declares light speed constant in all frames. And I've talked about this before, that it seems to be an interpretation of the mainstream of Einstein's theory of 1905. It's not really clear that it's that interpretation, but that's the interpretation that the mainstream places on Einstein. So the goalpost moves are Lorentz keeps the same absolute time framework throughout, and Einstein shifts from an ether to space-time as an ether. And that bit about Einstein shifting from ether to space-time as ether, that's a bit drawn out. He starts from 1905, where he mentions ether in that paper, and then in 1920 he has this idea that space-time is a type of ether, but it's all interpretation. What Einstein is saying is a bit vague. So it's Lorentz is not moving the goalpost in this situation, but Einstein is. Next is the Michelson-Morley experiment. Lorentz explains null result by proposing real length contraction due to motion through ether. This was a single postulate added, but within the same absolute framework. And Einstein uses relativity of simultaneity plus light speed invariance to reinterpret the result. So the goalpost status is Lorentz is no major shift, just one dynamical adjustment. So it's AI saying there's not much of a moving goalpost thing for Lorentz, but for Einstein, he redefines simultaneity and denies ether altogether. So that is still an interpretation being imposed upon Einstein, because I've argued in other videos that can't really see that he definitely means that sort of thing. Anyway, the goalpost shifting seems to be with Einstein more than with Lorentz. Number 3, time and clocks. Lorentz has moving clocks physically slow relative to absolute time. This is due to ether interaction. Time itself is absolute. Einstein has time itself is relative. Each frame has its own time. Later in general relativity, time depends on gravitational potential and space-time curvature. So the goalpost status is Lorentz clock slow, but absolute time is untouched. Einstein has redefined time multiple times. He's got special relativity velocity and general relativity gravity, and then coordinate dependent. So Einstein is doing quite a bit of goalpost moving there. Number 4, we have experiments such as GPS, and Lorentz is straightforward motion through ether affects clock rates. No moving definitions. Einstein, he switches between special relativity kinematics, general relativity, gravitational time, and coordinate conventions depending on context. So the goalpost status is Lorentz, one consistent ether-based cause, and Einstein shifts explanatory standards. So it's mainly Einstein doing the goalpost moving. So the AI conclusion is Lorentz ether theory preserves a single metaphysical framework, absolute time in ether, and interprets anomalies with consistent physical assumptions, while Einstein relativity survives by redefining basic concepts such as ether, time, simultaneity, gravity, which is moving the goalpost. So AI is saying, yeah, Einstein is doing a lot of goalpost moving. Lorentz is not doing so much. So I'm just pointing out special relativity seems the main theory doing the goalpost moving, and Lorentz theory is not doing it so much. But I need to check that when I ask a few more questions. So the question I put to AI is, does the Lorentz theory move goalposts? Question mark. And ChatGPT AI says, good question. Let's test Lorentz ether theory by the same standard. The same standard I've been talking about, special relativity. AI says, case 1, Michelson-Morley prediction, there should be ether wind effect. Result, null shift observed for that. And the Lorentz and Fitzgerald proposed length contraction of moving bodies as a physical effect caused by ether. And so AI points out this is a kind of adjustment, but it keeps the absolute time and ether framework intact. It introduces one auxiliary hypothesis, not a redefinition of the whole ontology. It remains testable, predicts other effects like time dilation in principle. So in my view, that's a little bit of goalpost moving, but not too much. AI brings up case 2, later developments, and Lorentz refines his equations into what became the Lorentz transformations, still within the ether and absolute time framework. He never abandoned the idea of a paired frame or absolute simultaneity. So AI then gives comparison to Einstein. Lorentz is one adjustment, which is the length contraction and clock slowing, but the same metaphysics all the way through, and the metaphysics would be from the Newtonian physics. And Einstein does multiple redefinitions, which is for time, simultaneity, ether, gravity, space-time, across decades. And the verdict is the Lorentz ether theory, slight adjustment, but not the goalpost, not true goalpost moving, because the framework itself, absolute space and time and ether, never changed. But with Einstein, you've got fundamental redefinitions amounting to real goalpost moving. Einstein is the one doing all the goalpost moving, and they're pretty big goalpost moving. So Lorentz did not move the goalpost in the same as Einstein. He added patches but never redefined the core principles. And AI then asked me, would you like me to show the differences with a Popper versus Lacoste philosophy lens, i.e. why Lorentz's adjustment might be progressive while Einstein's shifts are degenerative? And I said yes to that. And so ChatGPT gives me the analysis for now. Lorentz versus Einstein using the two different philosophers. For the Popper philosophy, you got the forcibility standard. Popper's rule: a scientific theory must make falsifiable predictions. It dodges falsification by ad hoc fixes. It then degenerates into pseudoscience. So for the case of Lorentz, he's got the ether theory predicted in an ether wind, and the Michelson-Morley experiment contradicted that, and so Lorentz responded with length contraction and clock slowing, which made new predictions: Doppler shift, time dilation for fast particles. And the theory is still falsifiable. Could in principle detect the ether by other experiments. Whereas for Einstein, you've got the declared light speed invariant in all frames, but this is a partly definition, and it comes from clock synchronization convention. So when anomalies appear, and that's in GPS and so forth, relativity is reinterpreted rather than falsified. For Popper, this means looks like goalpost shifting, and it's weakening the falsifiability issue. So from this view, me saying this, so from this view, special relativity should be the one failing, and we should go with Lorentz theory. So AI going with Lacatos treats things as a research program. His rule is a research program can be progressive, and that's where it adds hypotheses that lead to new predictions and new discoveries, or it can be degenerative, and it adds hypotheses only to patch failures without predictive fruit. So for the Lorentz program, based on that philosophy, it's hardcore, where he's keeping absolute time and ether, and they got the protective belt, where he's got length contraction and time dilation. And is it progressive? Yes. Explained the Michelson-Morley experiment, predicted real clock effects, later confirmed, and that's for that one. And for the Einstein program, it's hardcore, it's keeping the relativity principle and invariant light speed, and it's got the protective belt, keep shifting. It's no ether one moment, and then it's gets shifted to space-time as ether, and so forth. Relative time gets moved to space-time, curved space-time, and you've got the kinematic time dilation leading to gravitational redshift and so forth. And so it's progressive at first, got light bending, gravitational waves, but many changes look like degenerative patches, especially with quantum theory mismatches and GPS explanations requiring case-by-case juggling. So the AI summary is Lorentz ether theory from Popper. It's falsifiable, which is a good thing. You want a theory that can be falsified. And lactose is it's progressive because it predicted measurable effects without redefining the framework. And then case of Einstein's relativity, special relativity, Popper, from a Popper philosophy point of view, it weakened falsifiability, which is a bad thing. The theory doesn't want to be falsified, it's trying to defend itself, and it does it by redefinitions which are goalpost moving. And from the lactose point of view, it's initially progressive, it's because it's given about mercury and light bending and so forth, but increasingly degenerative. It's goalpost shifts instead of clear predictions. So according to AI, from both philosophical points of view, special relativity is the main one doing the goalpost moving, and not Lorentz theory. So here we have a table of what's going on, so you can read it yourself if you like. And so the criterion is the core framework, the hard core. For the Lorentz theory is absolute space, absolute time, ether is a medium. And for special relativity and general relativity, the hard core is relativity principle, invariant light speed, and that's invariant light speed really in the context of the initial frames I pointed out at the very beginning slide, and there's no preferred frame. And then its next criterion is reaction to Michelson-Morley experiment. And Lorentz theory had to add length contraction and clock slowing, and Einstein had to redefine simultaneity and abolished ether. So I keep pointing out this interpretation of Einstein from the mainstream, and it's when you read Einstein himself, these things are not really that clear. But anyway, next, taking the view from Popper, where forcibility of a theory is important. Lorentz theory is still falsifiable because it could, in principle, detect ether, and a theory being falsifiable is a good thing. Next, with Einstein's relativity, it weakens falsibility. It's got the invariance partially definitional with the synchronization and convention, and so it's Einstein's relativity is not so good because it's defending itself. It doesn't want to be proven wrong. So from Popper's point of view, that's a bad thing. And so from the lactoses, which is looking at the philosophy of being, is it progress or versus degeneration, Lorentz theory is progressive. It's contraction stroke time dilation explained the Michelson-Morley experiment and predicted new effects. And whilst for the Einstein, it's mixed as to whether it's progressive or degenerative. And it's early on it is progressive, and later it's degenerative with its goalpost movement basically. Next is the goalpost movements, is a question mark, and so Lorentz theory is minor adjustment, and the Einstein one is major redefinitions. So you've got big goalpost moving with Einstein. So AI gives the overall verdict is Lorentz theory's consistent framework patches stay inside core metaphysics, and that's quite a good thing. And if we got for Einstein, he moves the goalpost by redefining its own fundamentals. So Einstein is the main one doing the goalpost moving. If you stayed with Lorentz theory, you wouldn't have had all these big goalposts moving. So AI is pointing out, so visually Lorentz is consistent but patched. Einstein is shifting foundations, goalpost moving. And so my next question is, does mainstream accept that Einstein relativity move goalposts and must be wrong? I mean, that's unfortunately a philosophical point of view. That a theory that keeps moving goalposts should be interpreted as wrong. But other people have other views, and ChatGPT says no. Mainstream physics does not accept that Einstein relativity moved goalposts in a way that makes it wrong. And then it wants to go say why. So Einstein's moving goalposts, but mainstream doesn't want to take that as meaning the theory is wrong. AI then points out that number one, mainstream view of consistency. Physicists treat special and general relativity as internally consistent frameworks. What you call goalpost moving is often interpreted as extension or generalization, not a fundamental shift of the theory's core. So, what it's pointing out to me now is what I'm calling goalpost moving. Physicists don't want to interpret as goalpost moving. And AI gives the, for example, going from special relativity to general relativity is seen as moving from flat space-time to curved space-time, a natural generalization, not a change in the hard principles. Number two, predictive success outweighs historical shifts. Relativity's predictions, such as light bending and so forth, with the corrections have all been confirmed. Yeah, there's a bit of shifting there going on there. You could put corrections on. Anyway, mainstream science emphasizes empirical success more than metaphysical goalpost purity. Number three is interpretive flexibility is not considered falsification. And this is what the mainstream point of view is. Reinterpretations like space-time as a new ether are seen as clarifying concepts, not abandoning core principles. And so time dilation, simultaneity, and coordinate-dependent effects are treated as different perspectives within the same mathematical structure, not a shift of the goalposts. So mainstream is refusing to see the goalpost moving. And number four, the philosophical stance. Philosophers of science may debate degenerative versus progressive research programs, but mainstream physics evaluates predictions, experiments, and consistency, not whether historical metaphysical interpretations moved. So they're abandoning taking account of the history of what's going on. The physicists are not paying attention to the history of what they're doing. They're just moving goalposts, but they're not paying attention to that. So AI points out the bottom line. Mainstream physics accepts Einstein relativity as correct within its domain of empirical validity and does not claim it is wrong just because some historical interpretation changed. Once again, pointing out, mainstream doesn't pay attention to its history and what it's doing. If you want, I can break down this is AI saying, if you break down, I can break down exactly which goalposts move, mainstream physicists accept versus reject, so we can see where the disagreement lies. And so what is going on here, it's sort of like mainstream accept some goalpost moving but not other goalposts moving. So I say do it. So AI goes on and it wants to go into details about what I asked it to do. And it says, let's list the main goalpost move in relativity history and mark clearly which the mainstream accepts and which it rejects. So you got this idea of ether to no ether to space-time, and it's all Einstein's mess from 1905, the special relativity paper. And first of all, he interpreted it as discarding ether as unnecessary. Then he gave his 1920 lecture where space-time became like a new ether, but different properties. And so AI gives it a tick. Mainstream accepts this shift. And the mainstream, they don't call it goalpost moving, but reinterpretation of ether as geometry of space-time is normalized. They reject the old ether idea but accept Einstein's new ether. And AI goes on, it says next issue is about the time shift. Time became relative, and you got gravitational time. And then, so time dilation depends only on velocity, that's the first thing. And in 1915, time dilation also depends on gravitational potential. AI gives a tick. Mainstream accepts this as generalization. And they, the mainstream, see general relativity as extending special relativity, not contradicting it. In practice, it was a redefinition of what time means. Next, AI gives simultaneity to frame dependent to convention dependent with GPS and so forth. Simultaneity is relative to inertial frames. And later, you had the one-way speed of light cannot be measured directly, leading to simultaneity is conventional and so forth. So mainstream accepts that, or accepts relativity of simultaneity. Mainstream accepts convention debates as philosophical, but they don't see that as undermining special relativity. And now mainstream gives a cross. Mainstream rejects Sorelli type absolute simultaneity or preferred frame simultaneity. And so suddenly we got, and they're suddenly bringing in this Sorelli bloke. He's been theorising some things. AI then goes on to number 4, time dilation, to leading to clock effects and the relativity of time versus measurement. Early critics Lorentz, Poincaré saw dilation as apparent effect due to dynamics and synchronization. Einstein and mainstream interpret it as a real effect on time itself. So tick given by AI for mainstream. Mainstream accepts the stronger interpretation. Time itself changes. Cross mainstream rejects Lorentz's interpretation. Next comes the Newtonian mechanics, leading to low speed approximation of relativity. Newton treated as true until 1900, and then that changes. Einstein reframed Newtonian physics as a limiting case of relativity, and I find that dubious. I read him and don't really make that out from what he's saying, but that's once again the interpretation given by mainstream. So mainstream accepts Newton as the approximation, and the cross is mainstream rejects Newton's absolute space and time. So what we have is AI leading on to issue 6, length contraction, leading on to the idea of geometry of space. And for Lorentz, you've got moving rods contract physically due to ether interaction, but for Einstein, you've got length contraction arises from geometry of space-time. So AI says tick, mainstream accepts Einstein's geometric explanation, but cross mainstream rejects Lorentz's explanation. On to issue 7, light speed is always constant in special relativity, and that's in the context of inertial frames, leads to curved paths. And so what we have is light always moves at c in any inertial frame, but in general relativity you've got locally always c, but globally light paths bend in curved space-time. And tick mainstream accepts both and calls them consistent. And then cross mainstream rejects variable c in a preferred frame. So the AI summary is the goalpost moves, mainstream accepts is the following: ether leading to space-time, ether, time dilation leading to gravitational time, simultaneity leading to frame dependent then conventional Newton's approximation of relativity, length contraction leading to geometry not dynamics, light speed constant locally but curved paths in general relativity. So you've got all those goalposts moving going on, and the goalpost moves that mainstream rejects are the following: Lorentz's absolute time and dynamical interaction, Shirelli, or you got Shirelli again we have mentioned, Shirelli or ether-based simultaneity, variable one-way light speed to preferred frame, and then it's Newton's absolute space, and time is fundamental. So AI says the mainstream accepts some goalpost moves, calls them generalization, but rejects others, calls them wrong or unnecessary metaphysics. So the last comment is what leads me on to something else I want to investigate. So what we are left with now in part 3, it's totally mysterious why mainstream rejected Lorentz theory. But what I want to know now is why they're accepting some goalposts moving and not others. And also the issue of Shirelli has suddenly been brought up, and I've also got to go into that. You got Shirelli transformations. It's another issue. So to be continued.